school summer is like a really, really invaluable time for students to explore their interests of what they want to continue pursuing in high school and beyond. And so it's really important that you choose wisely which program you want to send them to, because whatever they're interested in during the summer, they can very easily just continue to pursue that throughout high school and beyond, and really focus their time and efforts into that area. So yeah, the middle school summer is such an excellent opportunity for your child to really explore what they want to invest their time in high school. And yeah, all right. So this is the story of ecotechlab. So ecotechlab was founded essentially to solve a gap between the current state of technology and the desired state of technology. The current state is quite environmentally destructive, as a lot of us are aware, and the desired state would be technology that isn't nearly as environmentally destructive. In our summer program, we focus on sustainability in terms of carbon emissions. And so for every major organization government in the world, one of their top priorities is achieving net zero emissions by 2050. So what that means is however many carbon emissions we release into the atmosphere, the goal is to take that many carbon emissions out of the atmosphere to be at net zero. The problem is that achieving this by 2050, which is only 25 years, is very, very difficult and will require a lot of innovation and technology that simply doesn't exist yet, primarily in carbon capture and other negative emissions technologies, as well as scaling up renewable energy. And so our goal with Ecotech Lab is to solve this problem, which is how do you achieve net zero by 2050? And that is through educating and inspiring the next generation to want to pursue this field and actually innovate in this area of innovation. Sustainability and sustainable technology is a very new area of innovation. It's where AI was 10, 15 years ago, very early, very much confined to research settings in large organizations and academia, with very little, adoption on a mass scale. But I believe that in the next 20, 25 years, that will drastically change. And I think Ecotech Lab will be have played a part in doing that. And so we're taking this bottom-up approach to actually educating and inspiring the next generation to build the future of sustainable technology and yeah, just help achieve this goal of net zero by 2050. So that's the story of Ecotech Lab. Now, speaking a little bit about my background. So my background is mainly in software engineering. So I'm currently wrapping up my last year of my computer science degree at UT Austin, but I am finishing my degree remotely from the Bay Area. So during high school, during undergrad, I have had a lot of excellent experiences building really cool startups and working at really cool companies. So I was a founding engineer for High Five, which is a cashless tipping platform. I built their web dashboard that kind of does their data visualization and help them take the product to market, find initial customers like big hotel chains, Marriott, Spring Hill Suites, Radisson, etc. Then I was a founding engineer for Deep Perception, which is a computer vision startup. So what they do is they develop AI technologies for video surveillance in a bunch of different industries. So I built their initial product, similarly help them go to market and find initial customers. And then I was at Uber. I worked at the GeoSearch team in their Maps org. And then I was at Cisco. I worked on their IoT operations dashboard. And so all of these experiences have made me, given me a lot of insight, of course, into software engineering, but also into entrepreneurship, which is why I decided to start my own venture here at Ecotech Lab and really just pursue my passion for engineering by making sure that the next generation of engineers builds technology that's not only useful to humans, but also sustainable on Earth. And so that's really my goal, is to just be the best engineer I can be by helping the next generation be the best engineers that they can be. So that's my background. Now talking about the program. So the program is 100% project-based. That is very, very important to us. So our goal with the program is not exposure, it is mastery. And students only master by practicing what they're learning. And the only way to do that is through hands-on project building. And so that's why we do 100% project-based. The students will be building 3 different projects in 4 weeks in 3 different industries, as you can see here. They will be using the 5-stage design thinking process created by Stanford's design school: empathize, ideate, define, prototype, and test, to build these 3 projects. So going over the first project they'll be building is a smart water conservation system. So this project was really intentionally chosen to be the first project. It's a very great introductory project for students who don't have any prior experience in computer science or electrical engineering, which is what we're assuming all of our students do not have, to essentially have 0 prior experience. So in this project, they are going to use Arduino, which is a microcontroller, and a simple LED circuit to build a very simple embedded system. And they're going to use a very simple scripting language to actually power this embedded system and analyze essentially how much carbon emissions are saved by solving inefficiencies in water irrigation. So that's the first project. The second project is they're going to make a solar electric vehicle robot. So everything they learned in the first project in terms of building a fully embedded system, both software and hardware, using a simple scripting language and a simple microcontroller, now they're going to do that, but just take it to the next level. So instead of using an Arduino, which is a microcontroller, they're going to use a Raspberry Pi, which is a microcomputer. Instead of using a simple scripting language, they are going to build a full stack web application on their phone to remotely control their robot. So in this project, they'll be analyzing essentially renewable energy, how to actually power electric vehicles using clean energy, and also the possibilities for scaling up this technology in the real world. And then the third project they'll be building is going to be an AI carbon footprint calculator. So this is going to be a very robust full stack mobile application that incorporates AI, which is, something they can literally publish on the App Store after if they'd like. So whatever they learned in the solar EV robot project in terms of building a web application to power their robot or to remotely control their robot, they're just going to do that same thing, but just take it to the next level. And instead of using Python and JavaScript, they're going to use React Native, which is one of the most industry standard JavaScript libraries. For building full stack web applications. They're also going to incorporate an AI model into actually predicting their future carbon footprint. And so clearly there's a pattern here where with, whatever project they do in the next project, they're just going to take that and just take it to the next level. And so this is how they are going to definitely achieve mastery of foundational skills in computer science and electrical engineering. It's because they are going to be utilizing the same exact concepts over and over again in the different projects, right? In the first project, they're going to be learning the basics, variables, loops, conditionals, functions, right? They're going to be learning the very basics of, input, output pins, etc. And then in the next project, they're just going to do that and take it to the next level. They're going to continue using those same variables, loops, conditionals, functions, but they're also going to learn about endpoints, and they're also going to learn about creating components and stuff like that. And then in the third project, they're going to do all of that, but then just build on their knowledge even more. And so that's how they're actually going to achieve true mastery, is by utilizing the same skills and concepts over and over again in different technology stacks. And that is definitely our goal with the program. So if you're looking for a program that is more exposure based, where the student is more exposed to it and does something a little bit more light, because there are a lot of summer programs like that where the learning outcomes are not as tangible. This program might not be the best fit, because this program is all about mastery. Students leave with very, very tangible outcomes, 3 projects, and they leave with the confidence to go out and say, I can build any project I want in high school because I know how to code. I know how to build these embedded systems. I know how to build robots. I can do this in high school. So they really learn it well. So just going on now to the main learning outcomes of the program. So of course, the first one we already talked about, which is the foundational mastery of computer science and electrical engineering, because they're going to repeatedly practice the same exact skills in different technology stacks. The second one is systems and big picture thinking. So this is actually really, really important, and really important for students to practice, especially at a young age. So in the program, because we specialize and focus in sustainable technology, students will consider the entire Earth system in terms of the material flows of the Earth system. They will consider specific industries like tech, transportation, energy, and the different material inflows and outflows within those industries. And of course, they're going to be considering the inflows and outflows of the different projects that they're building. And this is really, really important in helping them get used to thinking outside of the box, thinking about things as systems, as inputs, processes, and outputs, as well as thinking about things on a large scale or a big picture. This is really important in helping students develop creativity, solve problems, and really set them up for pursuing engineering and entrepreneurship. And then the third learning outcome is empathy and solving consumer pain points. So students will actually be learning about communities all over the world that are most affected by climate change and really understand their situation and try to design with them in mind. That's really important for entrepreneurship, is understanding who's most affected by your product and how you want to actually adequately solve the problem for them, whatever problem they're facing, solve it for them. And so these learning outcomes are really designed to give the student a really well foundation in engineering and entrepreneurship. And those are really, really essential if we want the next generation of engineers to go out and build, revolutionary, sustainable technology, is to have all of these skills in terms of thinking big picture, being able to empathize with those most affected by climate change, and also just have the technical skills of being able to develop these technologies. So these are the 3 main learning outcomes. And then this is kind of a high-level overview at the curriculum. So week 1 and week 2, in week 1, they are going to be building the smart water conservation system. In week 2, they're going to be building the solar EV robot. In week 3, they're going to be finishing the solar EV robot and starting the AI carbon footprint calculator. And in week 4, they are going to finish up the AI carbon footprint calculator. Of course, I will be sending you this curriculum document after the call so you can take a look at it more in depth. But as you can see, every day starts with a review, because it's very important. These students are still very much at a young age, and they need to keep reviewing everything they're learning so that they can not only be learning new things every day, but also be mastering everything they've learned up to that point. So that's really important. One of my favorite days of the entire program is actually the last day of the program, which is a team feature challenge. In this day, students will be getting into teams, and they will be designing and building out a new feature for their app in a given time frame. So it's going to be like a competition, and all the students will compete against each other for a prize of who builds out the best feature. This is really supposed to kind of expose them to participating in hackathons and encouraging them to continue doing that throughout high school and beyond. And yeah, that's just one of my personal favorite days of the whole curriculum. Of course, I will send you this curriculum document so you can look at it more in depth. But yeah,